a new game which is not yet complete, but will probably be completed later to the next week, where this is freestyling, by the way.
I can see.
Where I created a player character which can run, and the directions are mapped to the WASD key. And the character also has a gun, and they're also able to sprint and switch between two different weapon types. The first weapon type is this one, which has a fire rate of 14 and recoils 0.05 meters, yeah. And it has a weapon damage of 2. And then the second one is this one has a fire rate of 18, so it shoots more, and it has less recoil because the bullets aren't as big, and it has 1 weapon damage. And I created a script which is like a bunch of code for the 2 guns. And basically what I did was I had a hit scan weapon, which is like just a base where you can inherit from this. Inheritance is basically where you have a main scene which you can like inherit off of to make different scenes that have the same properties. And if you edit this one scene, it will change all of the scenes. So you have to be a bit careful using these, and you shouldn't really use them too much. Or if like there's too many weapons or too many enemies or too many of one thing, you shouldn't use it. It can get a bit complicated if you like change the sprite or change the image of the first one, because then all the other ones will reset to the base image. So it's a bit thing. But I only had 2, so it's fine. So basically, in this one, which is called Hit Scan Weapon, I created a timer, which is the amount of time before the player can shoot again. And wait, never mind, I don't know what this is. I don't know what the timer is for, but I have a Raycast 3D. The Raycast 3D is like the bullet, and it's centered in the middle of the screen, where you can't see it from here, but I did a crosshair. I added a crosshair. And
what's the crosshair?
It's like, you know, in shooter games where you have that like white dot and then little lines coming out or little arcs or something.
The cross, okay.
Like it's something to show you where you're shooting.
The target.
Not the target, but like something to tell you where you're shooting at.
Okay.
Where you're shooting at. Basically.
Okay.
And then.
Is it to help you aim?
Huh?
Is it to help you aim?
Yeah, it helps you aim. It's like, you know what?
Yeah.
I'll just show you. I'll
Yeah.
show you. Look,
That,
you see
okay,
that thing
yeah,
in the middle?
yeah.
That shows you what you're shooting at,
Right.
basically. So, in this, in the base scene that doesn't have anything inherited from it, I've added a Raycast 3D, which basically acts like the bullet. Basically, it's in the middle where the crosshair is, and it follows the camera. So the Raycast 3D is moving, and when you press the shoot, it will like project, like go like that, and anything it's colliding with, or only the enemy, because that's the only thing that it's going to shoot, it will take damage from that, as you can see in this function. It plays the animation, fire, then it does a cooldown timer divided by the fire rate. So the cooldown timer is basically the base, yeah, it's the timer that controls how much they fire each second. By the base one is 1 second, and then you divide the base timer, the cooldown timer, by the fire rate to get the amount at which you're firing each time.
Right.
And then I do var collider equals raycast 3D dot get collider, which means whatever it's colliding with, you will be able to access it and write stuff to happen for that thing. Like, okay, it's better to show you. Well, this is the recoil, which is just how much they recoils. And then I did if collider is enemy, and then we were wondering how you just get enemy. Well, that's because in the enemy.gd script, I did a class name of enemy, which means that is now globally accessible to all the scripts. So now that can be used, and all the variables can also be accessed from outside the class, from outside of this enemy script. So
By anyone in the
No.
other scripts.
You're going to be able to use it.
No.
I don't mean globally. Yeah, anyway, so if the collider is, now there is a keyword, basically means like if the collider, if it is this, then do this.
Okay.
So if the collider is enemy, collider.hitpoint minus equals weapon damage. So collider, raycast 3D dot get the collider, and then I have to make sure it's enemy, or else I'll get some errors because like you're colliding with something that's not the enemy and it doesn't have the variable hit points, so nothing's going to happen. So now, to explain this, weapon damage is an exported variable, which means I can access it from the inspector. The inspector is, well, if I just click on the root node is the main parent node, and everything is just a child of it, and then those children can have children. It's a weird terminology, I don't know what's called that. So you see in Sub Auto Machine, this is the inspector on the right here, and it has all the exported variables like the recoil. If I increase the recoil, it will move back more, and if I decrease it, it will move back less. So this is also the weapon mesh, which is basically it's a node 3D, which is just like it doesn't have any properties. It's used to organize things, I guess. And I've chosen the weapon mesh as this thing, so that everything.
Which thing?
The hand and the gun.
Ah, okay.
So that everything in the code will basically happen to that, like the recoil. You don't want the raycast 3D to recoil. You know what I mean? Because then you might get a few errors, but it doesn't really matter. And it has a weapon damage of 2, which is also exported over here. So this is the inspector, and it means you don't have to, if it's exported, it means you don't have to like go back into the script, find the variable, and do it. You can just export it, and you can access it here. Okay, now where was I? So collider.hitpoint minus equals weapon damage, you know what weapon damage is?
Yep.
And then the collider is enemy, and the enemy has a variable called hit points. Here, look, var health equals 5. That's the amount of health the thing has. And then I have var hit points as an integer, and it's equal to health. Health is just the hit points, and it just has a bit of code like set value, setting the value to hit points equal to value. This is a parameter. And if hit points is less than or equal to 0, it will queue free the enemy. So as in it will get deleted from the running project. It will just go. I'm going to change that later. Probably. So it will just disappear. It will queue free. It's queued from the scene. A scene is like the thing that's run. That's a different scene. Instead of scenes. So I said if the hit point is less than or equal to 0, then queue free, and then go back into hit scan weapon. If the collider is enemy, collider.hitpoint, so you know hit points, that variable,
Mhm.
your minus equals weapon damage. So every time you shoot, it will minus from 4 to whatever the weapon damage is. Is it 4 or is it 5? No, it's 5. Yeah, it'll minus, minus from 5, 4, 3. So like, if you hit it 5 times and the weapon damage is 1, it'll take 5 shots, and that's 41 second divided by 14. That's the amount of shots each thing. So you'll basically be able to kill that like maybe 2 per second. 2 per second.
Mhm.
Yeah.
Kill to what?
Zombies
Zombies.
per second. Yeah. Hit points. That's just one of the enemy variables. That's all right. So then next we should probably talk about the player. So the player is a character body 3D, which means it has customizable physics on like how it should move. Because like if it was like a rigid body 3D, you just have basic physics and it's just like how stuff normally.
Yeah. Yeah. Go ahead.
So I have loads of variables here. This would probably be like the meat of the thing.
Yeah.
So this is just the hit points. I don't need damage, and I don't need speed either. Okay, so I have the hit points is equal to 4, and the reason I've done it as a variable is so that it can be changed later. I'll explain what I mean. So these are constants, which means they won't be changed throughout the whole of the game. They'll always stay at this speed. Oh, why did I just... No, I do need speed, never mind. Don't need damage. Yeah, there we go. Okay. So speed is... I think I use it later on, yes, the speed. So these are constants, and these will never change. These will always be the same. And see, I've got constant walk speed, which is a float. And I've got sprint speed, which is 4.0, which means it's like an average pace. And sprint speed is 6.0, which is a lot faster. And then I have jump velocity, which is, velocity jump,
Mhm.
yeah. And I have the sensitivity. I forgot what this was. Oh, sensitivity is, what's again? I think it's how, I think it's how far up and down you can go, look up and down, because you don't want to like do flips, you know.
Why is
So
it called
clamps.
why is it called sensitivity?
I don't know.
Doesn't sound.
No, it's speed. It's the speed.
Okay.
It's the speed of the camera. Just call it sensitivity. And this is these are Bob variables. I don't know. I didn't end up using these. This was a failed thing. It didn't really work. So these are FOV variables. So if you see in the scene tree, which is this thing on the side, which has all of my nodes, nodes like different things you use to do different functions. This is a camera 3D, and the FOV is the zoom. So now if you see the base FOV,
FOV?
is like the zoom,
Okay.
the amount that you zoomed in and out. So the base FOV is a constant, and that's 75, which is just like the basic one. And the FOV change, which is how because it will change the.
Wow. You can sit down if you want. You're getting tired.
No, I'm fine. The FOV change is 1.5, which is how it changes. This is variable gravity, which is gravity. I don't know if I use that. There's a lot of stuff I didn't use. So the var head is basically the camera. I just made an onReady. An onReady variable is where you can access a node from the scene tree into the script. So I've got onReady var head, which is the head of the character, which is like the camera pivot. Because if you don't have a node 3D attached to the camera, it gets a bit weird. And then I've got, of course, the camera itself. So then var instance I use later. Can't remember what for. So this is the function ready. Ready means like this line of code, these lines of code, will take place as soon as the node enters the scene. As soon as the node enters the scene. So as soon as it comes in, it will do this. So what I did was I set the mouse mode to mouse mode captured, which means the mouse is locked in, so you can like move around with the mouse. It's locked in.
Oh, okay.
No, as in you can't see it, and it's locked in. It's not because of you know what I mean. It's locked and you can't see it. It's captured. So this is unhandled input, which you can see a full definition for it. It's called when an input event hasn't been consumed by input or any control or anything. I haven't like completely learned unhandled input, but what I know is it's basically to control how I think the camera moves and how the mouse moves. But I'm not like yet done this. I haven't covered this very much. And this is if the event, as in if the thing is happening, is mouse motion, as in like if you're moving the mouse, because you know the mouse is still there, you just can't see it, and you can't move out of the thing. So if, which gives the illusion as if you're moving it with this, but it still works even after like you make the mouse visible. So look, if I said if event is mouse motion, so as in it's moving like this, then the head, which if you remember is the parent of the camera, if the head is moving on the x-axis, it's just so event or relative x move to the x and timesing it by sensitivity, which is how fast it's moving. And this is camera dot rotate dot camera dot rotate x, which is just up and down. It's just those. That's what it is. And this camera rotation dot x equals this line. It clamps the amount it can move up, down, left, and right. So it clamps it.
Clamping mean like it's just locked.
Clamping meaning
Just keep on going left.
it controls how far left and how far right it can move. The
Okay.
cam-
Oh,
like if it's
okay,
the
okay.
head, it basically means you can't go.
Right. Keep on going
Be
left.
like an
left.
owl.
Yeah.
Yeah, and it also means that you can't like bend over backwards.
Yeah. Okay, gotcha. So it mimics real life.
Yeah, so it's
head
like going
movements.
like this, and then like if you're like this is as far as you can go. So it
Right.
clamps it.
Gotcha.
And this is the physics process, which basically handles all the physics and stuff. Not necessarily just like everything. Not, you know what I mean? Okay. It mainly handles physics. Okay, here is, this is quite important because it means you don't have to like keep on doing opening GarageBand. It's if input is actually just pressed UI cancel. UI cancel is the escape key. So you say if that is pressed, input.mouse mode equals input.mouse mode visible, which means the mouse will now be visible and it won't be captured. It will be visible and it won't be captured, so the player can now move their mouse all around and can see everything. Now this is handling the gravity. We're basically saying if not is on the floor, which means if the player isn't on the floor, then velocity.y minus equals gravity times delta. Delta is just like the thing that it's like frames per second. It elapses every frame. I don't know how to explain it, but I don't really know.
Okay.
Delta. It's called every frame.
But you understand how to use it.
Yeah, I think I
It's
understand.
useful.
Yeah, it's useful, I guess. I'm not actually sure what it does yet. I am going to look into that. And gravity is how fast the player will fall down. Right now, I've got it at 9.8 because that's the gravity of Earth. Yeah, that's the gravity of Earth. I've got it. Huh? No, because it's the amount of gravity. Like, if I put it to 1.63 recurring,
Can you bounce it?
yeah, it'll go up.
Really? I didn't realise that. That's very cool.
Yeah, it goes. Woo.
Fine.
And velocity dot y is the speed of up and down, which it should be z, but I don't know. It's y axis. Doesn't it? It should be. I don't know. The point is, it's minus equaling gravity times delta. Gravity, you know what gravity is, and it's minus equaling because you're going down. So minus equals gravity times delta. And then this is handling the jump. We say if input dot is action pressed jump, which is the space key, and I've mapped it in the project settings. Actually, I'll show you that. This is project settings. I'll just keep it on. Okay, just leave it there for now. Input map. I've mapped loads of actions to specific keys.
Oh,
Right.
to make it faster?
No, it's not. Like moving forward is W. I've mapped the keys to certain actions, and I can use the actions in the code. So up is W, down is S.
That's
forward,
very clever.
forward and back.
Very efficient, no?
Yeah. Forward I don't need. Backwards I don't need. Up, down, jump, sprint, and shoot, and 1, 2. 1, 2 is like 1 will equip weapon 1, and 2 will equip weapon 2. But in the future, as in like after this presentation, I'm going to maybe
Change it to a mouse.
I'm gonna do the mouse for a
Right.
wheel, which we don't have a mouse wheel, but
Yeah.
it's just for a lot of people who do. Sprint is mapped to shift, and up, you know, WASD. And for right hand. Shoot is the left mouse button for all devices. Yes, okay, so here. If input dot is action pressed jump and is on floor, velocity dot y equals jump velocity. So basically saying if the input is just pressed jump and is on floor, then you want to jump, go up. And the reason you did is and floor is because you know this isn't. If you don't do the is and floor, that means you can like jump an infinite amount of times. And is action just pressed means like you press it once and it goes up. If you hold it, then you just jump. You don't want that. Just pressed. So it's only called when you press it once. If you hold, if it is actually pressed, then you just jump, and it's not as good. And then this is the sprint. So speed is a variable which can be changed at any time. It's just like how fast the player is going. So if input dot is action pressed, not just pressed, because you want to hold it to go faster. You don't just click it once and then you're at that speed for like 1 frame. So if input dot is action pressed sprint, then speed, which is the variable, is equal to sprint speed. The sprint speed is a higher number, so therefore you go faster, and it's a flow. So, otherwise, or else, speed is equal to walk speed, which is the normal speed. And then I've got here I've got input direction dot input dot get vector, which means I'm getting all the input directions and input directions dot get vector, which is like all the directions. Left, right, up, down. So now left is used for going -1 to minus on the x-axis, and right is going for plus on the x-axis, and up is going for minus on the y-axis, down is going plus on the y-axis, because I don't know why up is minus. Okay, now bar direction equals head transform basis dot y dot normalized. I think this is making sure the head moves at the direction of the head node and not the camera node. Because if it's the camera, the head doesn't really work as well. Because the head is a pivot.
Okay.
Okay, now here I've just got more. This is just direction stuff. It's like nothing. It's just basically the same thing repeated 100 times. It's nothing that important. I think that's also it was in the inbuilt stuff. Oh, I do have head bob. Oh, I thought I left it out, but I can't really tell. So head bob is just making it so that it's more realistic. So when you walk, the camera goes up and down a little bit. And I've got some constants up here. Var T bob. I think that's just like something. And this is bob amplify, I think, and bob frequency. Just how many times bob. Head bob. Yeah. So this just controls that. This is the FOV. This is the FOV thing. So, say var target FOV. So basically, what I'm doing here is I'm making it so that the FOV is more zoomed out when you're running, when you're sprinting,
Okay.
and
Makes
more zoomed, and then a bit more zoomed in when you're walking,
okay.
and then most zoomed in when you're idle.
Okay.
Uh,
So you see more of the body.
You see
When it's-
more when you're sprinting.
Okay.
You see less when you're idle. So I've also lerped it. Lerp is basically where you animate the movement, animate movement colors. So if you didn't have a lerp, it would just be the FOV would just change instantly. The lerping animates it, so it's a bit more smoother. Okay, now this is death. This handles the death. So this is if hit points is a variable up here which is equal to 4, and that's just the amount of health the player has. So I said if hit points is less than or equal to 0, then quit the game. I'm going to change this by adding a game over speed later. So yeah, that's if hit points is less than or equal to 0, get tree.quit, which means quit the whole game. And this at the end is move and slide, which you need for all of this to work. You just have to call this function. The function is inbuilt as well. Now this is just more head bob stuff, and that's the end of this script. Oh, there's also this. This is quick. I'll just do this. Now this, so I've got a few export variables here, which is export var weapon 1 and weapon 2, which if I go into the weapon handler node, which is just a node 3D, which I can add stuff to, it handles the weapon changing. So if you see here, I've got a few export variables here where I can change what the weapons are. And then I've got from ready, equip weapon 1. Equip is a function down here which handles which weapons are working, or which weapons are visible. And okay, look, I'll just show you. If child is equal to active weapon, equal, or because you can't do single equal, if it's equal to active weapon, and active weapon is a parameter which is a node 3D. If the child is equal to active weapon, child.visible equals true, so you can see it, and child.setProcess, so this is the process function here. This handles everything, like the shooting, it just calls another function that shoots, and recoil and other stuff like that. Which one is it? Oh, this one. So I'm setting the process to be true, so all of that code runs if the child is the active weapon. Else, child.visible equals false, so you can't see it, and the set process is also false, so the code doesn't run. So basically, if it's the active weapon, then that code will run and it will be visible. Otherwise, the other one is can't see it, and the process doesn't work. And then up here, I've got unhandled input, which handles input events, I think, mainly. So this if event is actually press 1, which is mapped to the 1 key, then it will equip weapon 1, which is the sub-auto machine gun. So it shoots a bit less frequently and does a bit more damage. If you press 1, and if you press 2, it will equip the second one. And then this one is function ready. No, remember ready. Let me just go to the... So, ready is like, where, do you remember it when it first enters the
Yep.
scene? So when it first enters the scene, it will equip weapon 1, which is the first one, and then these are to change weapons. Okay, that's all for that. Then there's the enemy script. So I've got, it's a character body 3D, you remember that, and I've got class name, do you remember that? It's globally accessible.
Yeah, yep.
This is, oh, I don't know this. So I've got access to the player here now. Var player is equal to a null, just for now, so it's like nothing. And then var health is equal to 5. I explained this already, didn't I?
Yeah, you did.
Yeah. So the attack damage is also an exported variable and is equal to 1. I've also kept everything like 1, 5, 4, because if you go too high, then it's just more complicated. There's no point. Yeah, so var attack damage is 1, which means the player's health variable will minus by 1. Are you filming yourself?
No.
No.
Why are you laughing?
I have to keep on telling the camera to follow you.
Oh, okay. Nice. The attack damage. Yes. So the attack damage is how much the player's health will decrease by when it attacks. So I've got a constant here of speed and constant of attack range. Attack range is, like how close it has to be to attack. And then I've got a player path, which is a node path, which is like allows you to access it. And I define this in the game one, where because it's exported, I can define it anywhere. It doesn't just have to be the enemy. Because if it was a normal variable, I couldn't access it in the game file, so I couldn't do it because the player character body 3D isn't in the enemy scene, so I wouldn't be able to get it. So that's why you have to make an export variable so it can be accessible from the game, and you define the player path there. So I've got the navigation agent, which is how the navigation works. And I've got the animation tree. The animation tree is, have you heard of state machine?
A what?
State machine.
No.
Okay, so it basically controls which state the enemy is in. So if it's in a
How many
state,
hits? How many hits it's taken? Stuff like that.
No. What animation it's in. So like if it's in an idle state, it won't be moving. It'll just be standing there doing basic animation. If it's an attack, if it's in a chase animation, it will be running towards the thing, and you make it to that. And then you've also got the attacking thing. So I've also got access to the animation player because I also need that. So in function ready, I've defined that the player is equal to the get node, which gets a node from the game scene. Player path is equal to player path. Player path is remember the player, so you have to define it immediately, or else it'll just be sitting there until it's defined. Oh yeah, here it defines it. Called frame. Delta is the elapsed time since the previous frame. The amount of time.
Oh, okay.
Yeah, okay, in the process function, this is basically something that's called every single frame. The velocity is a vector 3. I'm not sure. Nav agent, so remember the navigation agent, which is how it navigates to the player, is, so I'm setting the target position to the player's global transform, which is the position, the origin of the global transform, which is basically the middle of the player. So it's going towards the middle of the player at all times. So then I'll say our next nav point is get next path position, which means get the next position of the player. Get the next, get the next, get the next. So it always follows the player. So the velocity, this is just handling velocity, is times the speed, is just handling velocity. This is the animation tree. So I'm setting parameters and conditions for when this will happen, for when these animations will play. So I have animation tree, parameters / conditions, which is accessing, if you go into the animation tree, inspector, click on attack. Click on attack. Well, I basically set up a few parameters and conditions for when it will play. So and I also had a function that I'll get into later, which is target and range. So when it's in target and range, when the target is in the range, change to attack. And then if target is in range, animation player dot get animation dot get animation attack, which is the attack animation, dot loop equals true, which loops the animation if the target is in range. So if the target is in range, the animation will now loop, or else it won't loop. If I didn't have that, it wouldn't loop and only hit once and then freeze.
Mm-hmm.
Okay, and then I call the movement slide. So attack is, this is a print statement, I don't need it anymore. So the function attack, it says what to do. So it says player, which if you remember, player is equal to the player path, which is the player character. So if it's in, so say player.hit point, which is the variable earlier, remember? Minus equals attack damage, which is, the exported variable. So, that's all that is. So then we have function hit, which is called, it doesn't do anything. So this is function die, where basically says if the health is equal to 0, it will Q free it. And then here is target and range. If animatree.get parameters conditions to attack, if it's attacking state, attack range, blah 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 blah. That is the attack range. It defines if it's in here, do this. It uses the attack range. So that's the enemy script. But there's a few other things I wanted to say. So go into the animation and then go to attack. If you see, I've used I added a track and made it so it's basically I can call a function at a certain time in the animation. So where did I call it? So at the 1 second mark, I'm calling the animation, I'm calling the function attack, which takes damage from the player. Because you don't want to take damage when it's just like here. You want to take damage if it actually hits you.
Right.
So at this point, attack. And that point is like, I don't know, around here. Like when the hand, around like when the hand like this. Yeah. That's that. This is the game scene. In the game scene, it's the biggest file, so it takes a bit longer. I've instantiated the player, so it's now in that scene, and I created a level using some assets. I've got where these things are, pillars, and they're glowing red, and I've got a few trees, a few benches next to them. There's also I don't know if you can see that, a little road or pavement or guide, and you're surrounded by trees so you can't like escape. And it looks like the end of the map. So I've also got here's a few houses and like that thing. What is this called again? Fence. And I've got a few graveyards here. Oh, one thing. This is the world environment, which is basically how the environment looks, basically. If you see here, somewhere off in the distance, which you can't really see because I've got all the fog on, I've added a sphere to block the light source in the game, so it all appears a bit darker. And if you see here, I have made it so that it's really dark. I've added volumetric fog, and I've changed the albedo, which is basically the color, and the emission, so like what it emits, like a bright, and dark. I made it very dark, dark fog, so you can't really see as well. So it has like a darker theme, and I've got a few, everything's going red to create a more like scarier feeling. Yeah, that's what I read. There's some graveyards. These are crypts. Oh, the last thing. This is the navigation region 3D, which is basically what the enemy needs to navigate around the map. If I click obviously not going to click it now, but if I click the big navigation mesh here, it will, so I've added nearly everything that's in the, I've added most of the map as a child of the navigation region, so that the player knows so that the enemy knows to go around those things, or go around and go on top, to go onto those things, go around those things, and then I make the navigation mesh so that it creates a basic geometry for the enemy to go around.
Right.
It's like a collision for the enemy. And then you need the navigation agent to work around that.
So, what does the navigation agent, how does it work?
So, it's like the navigation region has like a server, and I don't know how to say this. The navigation region is, I added trees, road, graves, fence, floor, everything that's everything that's on the ground.
So is that where that character can
That's
move
where
around?
the enemy. That's what the enemy moves around.
Right, okay.
It shows it basically gives a path for the enemy.
Okay.
And like boundaries. So like it created a basic. I just leave that. I don't know how to explain this. No, I do. It gives an outline of the whole map. So it has the floor and then gives an outline of everything, so the enemy knows, okay, I'm just going to go around that then. So it's like a roadblock for it, so a stop sign, so not go that way.
Right.
You know?
Okay.
That's pretty much everything.
Okay. Nice. Can you give us like a quick demo of what we've got so far of the game?
Yeah, sure.
Can you make it big screen? Does it work
Yeah,
big
I'm making it big screen. Run. I'm going to change it though, because it gets a bit annoying.
Can I have a great...
Window. No, yeah, full screen. There we go. So now it's on full screen. If I don't die, I'm going to move these a bit back so I'm going to give me time. So, yeah, it's now full screen. It's mapped to the WSD key, so I'm going to move the WSD this way. Okay, look, so I've got the player character, and click it on. So these are all the enemies, and look, I'm sprinting backwards. Oh, it's a bit laggy because it's in full screen. I've got these, and I'm going to switch to the second weapon.
Oh no.
I switched it. It's hard to explain what I'm doing. So I switched to the second weapon, which has a firing, less damage. I'm not sure which one's actually better. Probably the faster one. But yeah, that's all.
Cool.
Why did they all spawn like that in the
Oh,
beginning?
because I am going to add an enemy spawner to spawn the enemies so that they accumulate slowly.
What's the working title of the games? I don't know.
Oh, I don't have one. Right now it's just called FPS Revamped because I tried doing FPS like a few months ago and it turned out really badly. I just got loads of errors, loads of bugs, even when I followed the course, it just didn't work out.
Okay.
But now I've revamped it and everything is working fine.
Cool. So, what's your plan for like next week? What's your?
Oh, next week, I'm going to add an enemy spawner. There's not actually that much to do. I'm going to add an enemy spawner. I'm going to try and add a few more weapons. I'm thinking of maybe, I'm not sure, I might add a few different levels and it'll have like different things you have to try and defeat. So like in this one, it's a dark atmosphere and you have to defeat all the zombies. You might have another one, it's like a tech atmosphere and you have to defeat all the drones or robots.
Okay.
Something like that. Or you might have another one where you're a zombie and you have to try and defeat the human.
Oh, nice.
That's different.
Nice.
That's all.
That's it.
Yeah.
Well done. Very
Right,
good.
Guys, how long do you think
Very
that was?
good.
10 minutes?
You think you took 10 minutes?
Yeah, how much was it?
Right now, 46 minutes 23.
46 minutes?
Yeah.
Really?
Yes.
That was 46 minutes?
Yes.
That did not look like
Alright. Alright, so you're gonna say goodbye?
What?